Good afternoon, friends. Let's start with another topic of same quantitative technique. It's a quantitative approach. It's a new topic. Quantitative approach. What exactly we have learned till now in quantitative techniques, how we approach for that quantitative technique according to the management side, how the managers can use the quantitative techniques, quantitative those things we are going to learn today, in which we have clubbed all the things what we have learned till today, decision theory and all. So it will show you the approach towards the manager who learn the quantitative techniques and how they apply these quantitative techniques in their day-to-day life, regarding if you are looking for statistics, and then if you're looking for some fundamental things regarding the graph, because the most of the sales guy have seen that they have used the graph for their day-to-day sales approach, or quarterly or yearly. So what these things we are going to learn, I have clubbed each and everything in that quantitative approach, and we are going to learn these things over here. Let's start with the quantitative approach. So what is the topics we are going to cover over here? So I have put over there, see the management science approach to problem solving, how we solve the problem in the management science. Then we have a model building, which is also include the break-even analysis. The break-even analysis, hopefully you have learned in economics. Economics have covered this break-even analysis, but still we are going to learn over here the break-even analysis. Then the computer solution, we are going to learn how the software computer will solve the management, the queries related with the management and all, with the help of Excel and some other software. And then management science of modeling technique, what exactly the modeling technique we can use over here. Then business use of management science and technique, and then the management science model and decision support system. There is a few model which we are going to learn over here, and their approach towards solve the issue of the business, and how we utilize these model in our approach in the management. Then management science uses scientific approach to solving the management problem. We are basically using some scientific approach. See, whatever we have learned till now, either if you're looking for the linear programming problem, what we have seen, we have learned the game theory, we have learned the transportation problem, inventory model. These all are here and there. Somehow we are using the scientific technique to solve these problems. So it is used in a variety of organizations to solve many different types of problems. There are a lot of problems which we can see or we can solve with the help of different techniques we are using over here. It encompasses a magical mathematical approach to solving a problem. Some mathematical approach, what we have seen in the even yesterday class and before the yesterday class, we have seen there is a lot of mathematical approach through which we are going to solve the problem. You can see that the management science approach over here with the help of this diagram I have kept over here. See, initially, what is the approach of the manager? What is the manager going to approach when he faced some problem, he or she faced some problem? We have find out with the help of the graph, with the help of the figure. I have created one model over here. This is which is called management science technique, and with the help of that we are going to see when the problem has come, how the manager should approach on that problem. See, when the problem has come, suppose you are working in an organization, either you are a salespeople, or you are working in HR side, or you are working in suppose in I can say project management. If you are project manager, suppose I am taking the example of a project manager. Suppose project manager, he is facing some problem, might be some issue has come in the client side, and the project manager responsibility is that over there when they got the issue from the client side. So project manager is responsible over there to solve those issues as soon as possible, so that the feedback is very important. Feedback which the project manager got from the client side is very good if you're going to solve those issues as soon as possible. So we have start. So observation, we have start with the observation. When you got any issue, when you got any problem, suppose the project manager has got some problem from the client side or customer side. So what he will do the observation, what exactly the problem, how we can solve this, how many resources we are going to involve to solve this problem, and how much time it will take. So these are the observation. For these observation, they approach their subordinate. With the help of subordinate will create one documentation. While getting the data from the customer side, they will get the data from the customer. They will do the observation on the error, or I can say the issue what they are facing. So they will do the observation. In observation, they will create the documentation of that observation, and they will try to solve how they solve the issue, their approach towards solving the issue. They will track down in a, I can say, in a paper and pen. They will take paper and they will track down each and everything. They will do according to that. So this is all the observation of the particular issue or problem. Then the problem definition, what exactly the problem. See, there is a lot of problem when if being a developer, when you're doing a things, when you either you are looking for sales, when you launching a product or you're going for product sales, there is a lot of problem. So which kind of problem you are facing, that is also very important thing, which kind of problem you are facing. So problem definition, there is a lot of problem. Either you are getting some error, either you are getting some warnings or something in the system. Suppose if you create one software, if suppose you have created one software for your client, so what kind of errors, the issue, the problem, I mean the customer has faced. So you have to bifurcate that problem. What can there is a lot of problem. So you have to identify that problem and you have to give the definition of that problem. I mean to say, so either it is a warning kind of a problem, it is an error or some other issue. So you have to identify those issue or problem and you have to give the definition for this. Then we will create a model construction, how you are approaching towards the problem. So in this model construction, you are about to how to start to solving this problem, and in this area who is the expertise on those areas. So you will approach to them just like in the team. Suppose there is a team of in a under project manager, and different there is 8 to 10 people under that project manager, and each and every person, each and every subordinate of the project manager have their expertise in their own area. So you after identify the problem definition, you have to identify the resource, which resource going to solve this issue as soon as possible. So you are approaching that particular person or that particular resources over them, and after that you will get, when you reach that particular person or resource, then you about to get the solution. You're not getting immediate the solution, but after the issue has known by that person, he will go on to this issue, he will read the issue, he will go on to your papers, what you have done, each and everything he will read carefully. Then he will he can or he may be reach to some solution that this is the problem and how we can tackle this. So he provides the solution, and after he provides the solution, it will going to I can say that there should be some superior to that particular person that's going to approval in the sense you can't do anything. Suppose you are working some software in any software company, so you cannot start directly implementing those solutions. So there may be some, if you start directly to implement those solutions, might be there is some other issue may occur. So at the time when you're doing something on your development side, so at that time the same in the you have to confirm that the customer did not use that particular I mean to say that particular scenario, that particular software they have now used. For a timing, they have to stop using those software so that you can implement, because they are using the same software. You are doing any coding or you are starting developing your side, and the same software used by the customer from their side. So might be there is some other issue may occur. So you have to take the permission from your superior. Then you have to start the implementation. So this is the cycle. This is the cycle. I can give you some more better example when we are going to learn SAP. We are going to learn SAP ABAP. So in which I will give you the real-time scenario how we will working in SAP ABAP. We are doing the same, we are applying the same management science approach in the SAP ABAP. When we are getting some real-time issue, so how we will solve the issue, and after that how we'll implement those issue in a real time. So we will see these things in the real time, how we will do. So then steps of the management science process: send observation, identify a problem that exists in a system or organization. What I have told you. Definition of the problem. Problem must be clearly and consistently defined, showing its boundaries and interaction with the objective of the organization. Third is model construction. Development of a functional mathematical relationship that describe the decision variable, objective function and constant of the problem. Model solution. Model solved using the management science technique. Model implementation. Actual use of the model or its solution with what we have seen. So problem definition. Example of a model construction. So some first one is a problem definition. Then example of a model construction. There is some information and data you will get. Suppose business firm makes and sells a steel product. There is a lot of steel company, so you can take example of any of the companies like Tata Steel or some other Hindustan Zinc or any product. Product cost is around $5 to produce. To produce a single steel, suppose they are creating a steel plates, small steel plates. The cost of that product is around $5, including the labor charge, each and everything. So you can see that this $5 product cost is $5. In this $5, they have involved your cost of the raw material, your cost of the labor charge, your electricity, your rental, each and everything has been involved in the $5. So product cost is around $5. Then product sales for $20. Product cost is $5. You are selling the product in $20. So product requires 4 pounds of a steel to make. So how many pounds they require? 4 pounds. Here they have used, you can use 4 kg. 4 kg of steel required to make. Firm has, I can say that in the place of pounds we can use 1000 kg of steel firm has. So business, what is the business problem? Determine the number of units to produce to make the most profit given the limited amount of the steel available. So this kind of scenario will come in front of you when you are working in any company. So this much of product I can say raw material we have, and basically the person who is working in a manufacturing industry, this kind of scenario is coming, that we have this much of raw material. In this raw material we have to make this much of finished product. So how will go? So approach, your approach will come, how we will approach in this scenario, how many resources you will involve, how many hours you will take to create this much of product. So these things, all these things have come over here. All these things have come over here, and you can understand the scenario how we'll go ahead with that. So you can see over an example, x is a number of units variable. We can see that decision, which is nothing but a decision variable. Here we can see that x is a number of variable, which is a decision variable. Z is a total profit. Z is nothing but total profit. And then model, we have seen that the $20 for the sales product, so $20 minus $5 your cost, product cost. So Z is a profit, how you maximize the profit. So $20, you are selling the product in $20 and in product cost is $5. So 4.x into 100 lb of steel, resource construct. This is a resource construct. So parameters, the 4 parameters we have used over here: $20, $5, 4 lbs and 100 lbs. Then formula specified with the model. See, Z is nothing but a profit. We have seen in the LPP, linear programming problem, we have seen the Z. Z is a total profit. So we have seen that the total profit is equal to 20x minus 5x. X is the number of units what we have taken. Subject to 4x is equal to 100 over here. So this kind of Forget this initially. We have seen this maximize and subject to be this kind of problem we have seen in the LPP, linear programming problem, where it's given the one profit equation and another is subject equation, where with the help of that we will calculate the profit, and we will hopefully, or do you remember that I have shown you how to plot these things in a graph. I have shown you those also. Hopefully you remember those things also in your mind. So we have plot these things in a graph, and I have shown you the graph. With the help of graph, how you capture the maximum amount, how maximum profit, how you these things even we can see over here. So this is a very easy problem. So you can see that when suppose your product cost is 5 rupees, or you're selling those products in 20 rupees. So what is the profit? So 20 minus 5 is equal to 15. That is your profit. So these things. So the same formula we have utilized. 20 minus 5, which is nothing but your profit, which is maximize. We need to maximize for maximizing the profit. You have to utilize this kind of formula. What is this? What's going on here? Yes. To maximize the profit, we have used this formula over here. Then model building, break-even analysis. How to do the break-even analysis? What you have got. So for the break-even analysis, used to determine the number of units of a product to sell or produce, that is volume, that will equate total revenue with the cost. So how we'll do the break-even analysis? What we required for break-even analysis, the number of unit of the product. Do remember number of unit of the product to sell or produce? What the number of unit we have produced? Suppose we have produced the 10 units. So 10 units. That is volume. How much volume we have created? Suppose we need to create suppose steel plates. So how many steel plates we have created? 10 steel plates we have created. Number of volume of that particular product is 10. That will equate the total revenue of the total cost. So how many cost we will get after selling those products? So total volume at which the total revenue equals total cost is called the break-even point. So break-even point is what? Total volume at which the total revenue equals. Total volume at which the total revenue will equal. The total cost is called the break-even point. So what is the profit at the break-even point? Always remember at the break-even point, profit always will be zero. Always remember at the break-even. Hopefully you learn these things in the economics, because these things were in economics also. The break-even point and what is the profit you will earn at the break-even point. So profit is always zero at the break-even point. So break-even point, model components. Fixed cost is nothing but the CF. Cost that remain constant. Cost that remain constant regardless of the number of units produced. Whatever the number unit you produce, cost is always constant. That is not variable to the your number of unit. Then the variable cost. Variable cost is nothing but a unit cost of production. How many unit costs you have been produced. So total variable cost. Then the function of volume and the variable per unit cost, which is function of volume V and the variable per unit cost. Then the total cost, total fixed cost plus total variable cost. Total cost is what? Total fixed cost plus cost is what? There is two costs we have seen over here, which is variable cost and one is fixed cost. So when you're going to add the variable cost and fixed cost, which is nothing but a total cost. So profit, difference between the total revenue, VP, which is price, and the total cost. So revenue minus total cost is your profit. Revenue, what the revenue you have generated minus total cost, which is you are going to give your profit. This is some model components which we are using in the break-even analysis. So computing the break-even point, how you compute the break-even point, let's see over here. The break-even point is the volume at which the total revenue equals total cost and profit is zero. So I have told you, always at the break-even point, profit will be zero. So the break-even point is that, read carefully, the break-even point is that volume at which total revenue equals to the total cost. Total, where the total, the point, break-even point, a point where total revenue is equal to the total cost. Total revenue is equal to the total cost and the profit is zero. When the total revenue is equal to total cost, so profit obviously zero. So V is equal to CF upon P minus CV. Example, suppose some Western clothing company have taken the example. CF is equal to $10,000, CV is equal to $8 per pair, and P is equal to profit 23 per pair. So we can put over here CF, we put the value, CV put the value, and CV put the value. So 667 pairs break-even point. You will get the break-even point over here. So this is the formula. This is the formula to get your break-even point. Remember that. This is the formula to get you break-even point. V is equal to CF upon P minus CV. So here each and everything you will get. You will get the CF, P and CV. You have to identify. So this is a break-even point, which is nothing but this is the break-even point. At the break-even point, always remember total revenue is equal to total cost, and the profit at the break-even point should be zero. That's it. So you can see over this loss, and this is profit. Loss, and below side, in the break-even point, below side is a loss and upper side is a profit. This is the total revenue. This is the total revenue, and here is this is the total revenue. This is the total, this point. This point is total revenue, and this point is total cost. So this is point where variable cost and fixed cost. This is variable cost and fixed cost. You will shown over here. So here is the volume and there is the revenue cost. We have plotted the graph between volume and the revenue cost and profit. Revenue cost and profit. You can see that there is a $1,000 and this is the volume. This is the cost over there. This is the volume. And the break-even point, when the total revenue is equal to total cost, break-even point, at the point where the profit is zero. The point where profit is zero, where total revenue is equal to total cost. This is the break-even point. Always remember, this is simplest definition for the break-even point. You have to remember where the revenue is equal, total revenue is equal to total cost, and the profit should be zero. That point is called the break-even point. Simple and easy. So in the break-even point analysis, so we got two break-even point over here. You can see that when you got new total revenue, so this point, new break-even point, where old total revenue, this is the old one which we have seen in the last picture, and here you can see the new break-even point we have come when this point, this is the new total revenue and this is the old total revenue. So we got a new break point over here. So now you can see that the new break point over here. So break-even analysis, which is sensitive analysis break-even model with the change of variable cost. With the change in price, we can see that this is a figure when the change in price. When the change is price, you can see the figure, and when the change is in variable, you can see the figure. In the change in price, almost the break-even point will come over here. Almost. See, this is the line of the total cost. You can see that in the total cost you will get the same, but for the when the variable cost will come, you can see that it will come in the total revenue. When the revenue, when the variable change in variable, then the value will come at the total revenue point, and when the change in price will come, the value will come at the total cost. So these things you have to keep in your mind. So old B point and new B point. So we can see that. So Excel, with the help of Excel, how you learn these things. So how you learn the formula, or how you will get the V. So we have a fixed cost of about 10,000. Variable cost is 8 and price is equal to 23. So we have put these things in the formula, which is D4 upon D, what I have told you. 10, 10,000 upon, which you can see the D4. This is the D4. D is here, 4 is here. So D4 divided by D8 minus D6. So D8 minus D6. So you will get these things from the Excel. I have teach you the Excel how you do these kind of formulating. You can easily formulate and you will get the value of V. From the formula here we can see that we have seen that V is equal to CF upon P minus VCV. Same thing over here. V is equal to CF upon P minus CV. This is the same. So break-even analysis for Western Clothing Company of volume. We have seen the volume analysis over here, and you can find out the value. So this is a spreadsheet initialization. You can see that. So we have found this. This is the data over here, and this is the break-even point what we have got, and this is the break-even point in the cost volume analysis. So click on the QM to access the break-even. You will get there is the option of QM. So you will get the QM to access the break-even analysis macro, intermodal or parameter. So this is the way you can also get with the help of Excel sheet. But we are not using here because these are mainly used in the real-time world. The same thing over here. So this is Western Clothing Company example what I have given you. So this is the management science model technique. Now we are going to, I have to use the break-even analysis. Just remember what is exactly the break-even analysis, where the total revenue is always equal to the total cost, and at the break-even point, profit always be 0. So management science technique. So what exactly the management science technique? We have seen the linear mathematical programming, where we have seen the linear programming, model, graphical analysis, we have done sensitivity analysis, we have done transportation, we have done transshipment, which is not there, and assignment problem we have done, integer linear programming we have done, and goal programming is not there. These things we have done. We have done the problem matrix technique, probability and static, we have done the decision theory, we have done the queuing. Network techniques, we have done the network diagram where the port and all has come, CPM and port. Analytic hierarchy process, non-linear programming. Simulation we have done, forecasting we have done, inventory we have done. In the CD, simplex method we have done, transportation and assignment we have done. Non-linear programming we have done, game theory we have done, Markov analysis, bench and bound method which is not there. So this all come under the mathematical science, management science of the modeling technique, in which we have done most of the things what cover to your syllabus. So just keep in mind these things we have done, and we are going to approach towards the management side with the help of these analysis and techniques. So linear programming, what we have seen till now, what is exactly linear mathematical programming? It's a clear objective restrictions on resources and requirement parameter known with clarity, certainty. See, actually I have teach you linear programming initially so that whatever the terms right now I'm using, so you are aware of those things. If I start this chapter initially in the first or second day, so you're not aware of these terms, linear programming, probabilistic technique, network techniques. Now I have teach you each and everything. So at least you understand the term. Might be you're not gone through the previous slides, so you're not might be not clicking over there what exactly how we'll solve the linear programming, but at least you know the term linear programming, mathematical programming. So there is a clear objective restriction on resources and requirement parameter known and with clarity. Probabilistic techniques, results contain uncertainty. So network techniques model often formulate as a diagram, deterministic and probabilistic. In the linear program, what we have done, linear mathematical programming, there is some kind of theoretical question. With the help of that, we are going to create one linear equation. With the help of that linear equation, we maximize the profit. There is a two technique. One is a graph, with the help of graph, and there is simple technique with the help of solving those directly. Then we have done the probabilistic technique, where we'll get the result. Then we have done the network technique, in which we have learned the PERT CPM. With the help of that, we are creating some network diagram, and we are getting the result from them. Then forecasting and inventory analysis technique, we have done the time and the forecasting. We have done we have shown you, I have told you the inventory process model, the inventory analysis. In the inventory analysis, what we have seen, it's about 2 lectures. I've taken the 2 lecture continue or regarding the inventory analysis. So you do remember what is the formula for EOQ. We have done the EOQ model over there. We have done the holding cost and some cost analysis we have done over there. So those things come under the inventory analysis. Then other techniques, we have done the variety of deterministic and probabilistic methods to specify specific types of the problem. So some application area where we have used this kind of problem, where project planning, capital budgeting, inventory analysis, product planning, and scheduling. So these approach what we have used in the last class, we can use those approach in these kind of management in the management side. So project planning is nothing but your project management related with the project management. Then capital budgeting is nothing but related with the finance side, financial management. Inventory analysis is your inventory management. Production planning, which is nothing but a production planning management, PPM. Then scheduling is also related with your management. So interfaces, application journals published by Institute for the Operation Research and Management Science. What application will see over there. So management science model, what exactly the decision support system? We have learned the decision theory. This is something related to the decision theory also. Decision support system is a computer-based system that helps decision makers address complex problems that cuts across different parts of an organization and operation. Basically, there is a different software now that in the market has come. So when you thinking of any problem, any issue, so those actually software has to be made to, I can say that, minimize your headaches. In the simple word, minimize your headaches, and they will solve the problems very easily using some mathematical terms. We can give you an example of Excel, and basically Excel can use a lot of things. You can do the mathematically. You can make a graph and all. So this is kind of decision support system. A decision is normally interactive, combining various database and different management science models, and solution technique with a user interface that enable the decision maker to ask question and receive answers. So there is an interactive kind of interactive, I can say, that scenario has been come where when you're getting the problem, you can ask directly answer and you will get the answer like that. So it's an interactive. It's not one way, it's a two-way communication, I can say that. So one-line analytical process system, which is OLAP, the analytical hierarchy process, an enterprise resource plan, which is nothing but an ERP. We are going to learn this ERP in the future classes, so you have to know about some analytical technical team techniques and types of decision support. This is all the decision support system. So decision support system are most useful in answering what if question and performing sensitivity analysis. We are doing the sensitivity analysis with the help of this. So management science model, which is decision support system, we can see that this is the user interface. There is something related with the software. There is a decision maker, there is an internet or e-business, management science model, and database. So these are all interact with each, I mean to say, they are all interacting with the user interface. So there is a two-way communication between decision maker and interface, internet or e-business with the user interface with the management science model, and user interface with the database model. So these are there is a two-way communication between these two. So when they ask any question, so they will get the answer like that. So typical business decision aspects. What exactly that is typical business decision aspect? Decision may be made by a group. Might be there is a possibility that when you are working in a group, suppose in a sales team, so might be there is a chances when you launching a product. So it's there is a group which discuss how we will going to advertise this product, how will what time we are going to approach in the market to launch this product in the market, and how much profit we will get, and what kind of I can say public we are looking, in which area we are going to approach this, how we are going to advertise this. These things, all the scenario will come over here when you're talking, when you're taking the decision in a group, when you're launching any single product. Then several possibility contradictory objectives. Obviously, when you're going to group, when you're working in a group and you're going to discussing about anything in the group, so there should be some objection over there also regarding the here and there. Then hundreds or thousands of the alternative. Obviously, there is alternative for each and everything. There is an alternative, so result can occur in the future. So attitude towards the risk. Obviously, there is a risk. What if scenario? What if this is fail? Suppose you're launching the product. What if this is fail? So every time the management is thinking about what if. Trial and error experimentation with the real. They can sometimes some of the company, they are doing the trial and error experimentation in the real system, may result in a loss. Experimentation with the real system can only be done once. Changes in the environmental one can occur continuously. See here, trial and error experimental basically come in the software side. When a software product, when you're going to sell any company, if you're working in a sales side, any software company, IT company, when you want to sell that product in any particular company, so before selling the product, they want to run a pilot run, which is called a pilot run. So for the pilot run, they will take that software, they will install in their organization, and they will check at least for a week time. Either it is working fine for that company or not. When they satisfied, yes, what the product we are going to take, it is as what we want, then they will give you the green signal for go ahead. So how are decision made? What methodology can be applied? What kind of methodology you will apply for this? What is the role of informational system in the supporting decision making? What is the role of the information system? What is the role of information in the sense? What is the role of IT? Information system is nothing but the IT. What is the role of IT in decision making? So we can see nowadays everywhere the information system has been involved. From in industry, I can say that in industry, no one is writing nowadays in the pen and paper. They will take a pen and paper and they will open their account in the bank. Suppose I can give you an example of bank. When you're going to open an account in the bank, they will not write each and everything, your details in any register or somewhere in a book, account book. They will not write. They have their system. They have their software which is installed in the system. They are doing each and everything in their own system. When you're going to nowadays, what happened? You can open an online account also. So they have given you the details over there in your system. In their website, you will go. You can directly put each and everything, your details over there, and you will submit. Even there is a facility, even you can submit the I can say digital in the digital form in the address. You will scan your passport or some driving license. You can scan and you can submit over there. You can scan your photo ID card. You can submit, or you can scan the PAN card and you can submit over there. You can scan your photo. You can scan your signature. Each and everything you can scan, you can submit it, then account will be opened within a minute. So these kind of facilities available in the banking system, what I've given you the example. But before in 80s or 70s, in the 70s or 80s, we are not that much of far ahead to that time. We are not using anything. That time we are, each and every account should be open on the book. There will be some account book, and there we are each and everyone opening the account and all the things. So DSS, which is nothing but a decision support system, which is involved over here nowadays. So system, there is a three terms I have used: DSS, decision support system. So system, a system is a collection of objects such as people, resources, concept and procedure intend to perform an identifiable function or serve as a goal. What exactly the system? System is nothing but we are the system. We are the system. The people, the resources, the concept, these all systems. So in the system in which we are working, which is also involved in the part of decision making or decision creating. So they have all right or choice to take their own decision for any support. Just like when any company, suppose Hindustan Unilever Limited or Procter and Gamble launch any product, so they have all right to take the decision. So who will gonna take decision? There is a group of people, there is a group of group of people who gonna take decision. So they have some resources, they have some concept behind to launching any product. There is some procedure, there is some for that they are going to perform these tasks. So this is all nothing but a system. So this is all nothing but a system. So system level hierarchy. All systems are subsystem interconnected through interfaces. So one system and there is a subsystem. So these two systems are interconnected with their interface. What exactly the interface? The structure of the system. Three distinct parts of the system. One is input, then process, then output. So example, just like when you're going to write anything in a computer system, so it is all input. When you're going to put, just like suppose you put A, so A will directly not, you can see the A immediately in a second time. But when you're writing A, the computer will not take directly A, it will take in bit form, 0 or 1 form. Because computer know only 0 and 1. So when you're writing A, it will go inside and it will start processing. So it is processed over there and it will show in the output. So it is taking some nanosecond time or less than that. So this is kind of input, process and output. So this is, I have given you the example. System are surrounded by an environment, frequently include a feedback mechanism. There is a system which is surrounded by the environment. Environment is nothing but the people, resources, concepts, all the things, and you will get frequently feedback for, just like you suppose you launch any product. So you will when you launch any product, so day to day or hour and hour or in every hour you will get some feedback on that. Suppose just I have an example I can give you that. When news channel has started some new concept in their news channel, so they have given you there is one number has been pop up over there in the news channel, and they want each and every time your feedback. So what you are going to do, they are asking either you like this concept or not. Just ring, send the message yes or no in this number. So this is kind of feedback they want. So this is the kind of way to work in the system. A human, the decision maker, is usually considered part of the system. I told you that the human being, or I can say the people, is also the part of the, he's a decision maker and he's also part of the system. The system, this is the environment, input, process and output, and here you will see the feedback. If the feedback is good, then you will get the good product. Otherwise, if they found some issue or they found something over there, again the cycle is been like this. So this is the boundary in this. This is the boundary of the system. How to identify the environment? Question. Two questions is how to identify the environment. Does the element matter relative to the system's goals? It is possible for the decision maker to significantly manipulate the element. See, does the element matter related to the system goals? Yes. Each and every element matter to the system goal. See, in the element, in the sense approach element matter to the system goal. What exactly the system goal? What exactly system in the sense decision maker? What is the goal of the decision maker? How they work? Each and everything depends on their elementary. It is possible for the decision maker to significantly manipulate these elements? No, it is not possible. So environmental elements, what is the exactly elements? It is shown over there. social, political, legal, physical, economical, and other some other issues, some other systems. So does the element matter relative to the system goals? Yes. Element in the sense there is some social element. It is very important. Suppose you want to you launching some product, and the political, it is not there might be some political issue over there, some legal issue over there, because nowadays what happen, for each and everything you require some legal certificate for that you're launching any product. Suppose I can give you an example of some Maggie, just like Maggie. Maggie has been banned most of the now in India, in most of the states. Why they have banned it? Because they found some issue over there. They found that I can say that some elements or something which is lead, which is called lead. Lead is very high in the in the Maggie content. So what the government has done, government has banned the Maggie on those states. So this is the legal issue with the Maggie. The same thing. So does or written over here, does the element matter related to the system? Yes. So it is possible for the decision maker to dignify or manipulate this element. We cannot do. No one can do even. No one can do. You cannot buy. You cannot. If the Maggie has been banned because some legal issues, so you can't do. You have to ban the Maggie because that is a rule. So closed and open system. What is a closed system? What is an open system? So closed system, it's a totally independent of other system and subsystem, which is totally independent. There is no dependency between the two system, which is called the closed system, which are independent to each other. Closed system are independent to each other. 1 second, I want to know how many slides are there. 85. Closed and open system. What exactly the closed system? So closed system is totally independent, which is totally independent to other system or subsystem, which is nothing but like a closed, which is closed, not and there is only their subsystem, that is. So closed system is depend on the its own or their subsystem. That's it. The open system is very dependent on its own environment. Open system which is on its depends on their own environment. Continue. Defining manageable boundaries is closing the system. Defining manageable boundaries is closing the system. This is shown over here. So a closed versus open inventory system. Just like we have given you the inventory system. Management science EOQ. In EOQ we have learned economic order quantity, which is EOQ, closed system. Just like factors, what is the factors? Demand. In the closed system, constant, but in open system, inventory DSS, decisions, variable influenced by many factors. Variable influenced by many factors. Unit cost, constant in the closed system, but may change daily. Lead time, in the closed system, it is constant, but in the inventory, may change daily. In the open system, variable, difficult to predict. Then vendor users in the closed system excluded from analysis, but in open system may be included in the analysis. And weather or other environmental, it is ignored, and here may influence demand and lead time over there. This is I can say that they have given you the differentiation between closed system and open system using some factors over here. An information system. So collect, processes, stores, and analyze and disseminates information for a specific purpose. What exactly the information system? Information system is a collection, process, storing, analyzing. These are disseminates information for a specific purpose. Is often at the heart of many organizations. Nowadays, information system become heart of every organization. Not many, I can say every organization. Information system become a heart. Without information system, you can't work. You become a dead. So each and everywhere nowadays, information system is very important. Either you are working in any small company or very big four company, any company you can tell from when you from security to each and everywhere, the information system play an important role. So accept inputs and process data to provide information to decision makers and helps decision makers communicate their result. Performance measurement, effectiveness and efficiency. Effectiveness is the degree which goals are achieved. Effectiveness is a degree to which we can achieve the goal. Doing the right thing. What is the effectiveness? Either we are doing the right thing or not. So doing the right thing is called the effectiveness. Is the degree to which goals are achieved. We are achieving the goal. We are achieving some goal. We have some goal in the mind. When you are working in an organization, if your sales, then for the salesperson, there is a goal. There is a target. So effectiveness is a degree in which goals are achieved. So if your effectiveness, your goal should be achieved. So doing the right thing. Efficiency is a measure of use of inputs or resources to achieve outputs. So efficiency, it's your own measurement. Either you can achieve this or not. So it's a measurement to use the inputs or resources to achieve outputs. So there is some resource. With the help of that, you receive the output. You achieve the output. You achieve the output. Doing the thing right. Here doing the right thing, or here doing the thing which is right or not. Then productivity. Productivity is your efficiency or effectiveness. Your productivity. Either you are doing the productive work or not. Either you are working on a proper manner or not. These things come under the productivity. Measurable. Several non-quantifiable conflicting goals. Several non-quantifiable and conflicting goals. MSS, effectiveness focus. So models, what exactly the models? Major component of DSS, demand, service and DSS. What you have learned about the DSS? What exactly the DSS? Demand, service and demand, support and service. Demand, support and service. Demand, support and service. Major component of demand, support and service. DSS, demand, support and service. Use models instead of experimenting on the real system. They are using models. They are not anything. They are not directly doing the real-time system. They are using some models to start to work. If they want to do some experiment. So instead of experiment the things directly to the real time, they are using some models. A model is a simplified presentation or abstraction of reality, which is not a model. What is the model they are using? This is abstraction of the reality. Reality is generally too complex to copy. Reality is generally too complex. So reality is generally too complex to copy exactly. Much of the complexity is actually irrelevant in the problem solving. There is many problem. There is many complexity which is much irrelevant while you are solving the problem. Degree of model abstraction, least to most degree. What exactly? Iconic scale model. Physical replica of a system, iconic scale model. Analog model behaves like the real system but does not look like it. They behave like a real, which is symbolic representation. Mathematical, which is quantitative model. Use mathematical relationship to represent the complexity. Use most DSS analysis, decision system science. DSS stands for decision support system. Then we have used the mathematical quantitative model. So we have seen that when most of the time we are applying the mathematical quantitative model over here, use the mathematical relationship to represent the complexity. So we are using the mathematical model to represent or to get the output. Just like in the linear programming model, when you get a question over there, so you didn't get any, I can say that there is what the question you will get. With the help of that, you have to create one linear programming, and you have to create at least 3 equations, On these three equations you will solve, and then you will get the result. So same thing they are saying here. So mathematical quantitative techniques we are using a kind of model. So benefits of the model: time compression, easy model manipulation, low cost of construction. So you can construction cost is very low. Low cost of execution cost is very low. Especially that of error. Especially that of error. Can model risk and uncertainty. Can model risk and can model a large and extremely complex system with possibly infinite solution. See, there is sometimes you cannot find the exact solution. There is some complex problem will come which is not able to solve you cannot solve without using the mathematical model. So you have to use the mathematical approach to solve those kind of problems. So most of the time in the management, using the mathematical approach to solve these kind of problems. Either you are going to for economics, in economics also we have a lot of mathematical approach to solve some kind of issue. Then enhance the reinforced learning and enhance the training. There is a lot of training happening. Then the computer graphics advances. Complement math model using more iconic. Complement math models more iconic than analog models. So visual simulation. This is simulation. There is a model in the computer graphic which is called complement math model. Complement math model using more iconic and to the analog models. So modeling preview example. How much to order for the MAPA grocery? Some grocery we have to give you the order. So the question, how much bread to stock each day? So several solution approach. So there is a lot of approach. How you order the grocery, this example modeling view, and how the stock we have to, how to make the stock. So these things you can you have to, in this simple example, these can be calculated through help of some mathematical model. Just like in the how much order of the MAPA grocery, so order how much requirement we have, we will know according to the footpath of the customer, how much customer are coming in the daytime, how much customer are coming in the noon time, afternoon and night. So how much sale we are doing in a month or quarter, according to that they are going to give order. So for these they require some mathematical approach to do this. The same thing in the what they have done, how much bread of stock each day. So for these you can use some solution which is trial and error, simulation method which is basically used, optimization technique and heuristics techniques basically used in these to solve these kind of problems. I have told you that we will do one simulation problem to solve this kind of one issue. So decision making. Decision is a regional choice among alternatives. It's a regional choice. It's a reasoned choice among alternatives. Example, where to advertise a new product. From just like decision. This I have told you. Decision come over here. Where to advertise a new product? Where? Suppose you're launching some niche product. So you cannot advertise those products in a small area. I mean to say in a town or in a village. Because the capacity of the people over there is not to buy that product. So you have to launch these products in very big metro cities where the people can buy. So what stock to buy?